now we are going to transition from interesting images to boring text. Okay, so the idea of this workshop, you might be thinking, what is the theme, right? So someone is coming and talking about images, someone is coming and talking about text. So if you're looking for an underlying theme, the theme is modeling unstructured data. Okay, so when you think of unstructured data, it is primarily images, text, right? Not the so-called fancy tabular data. So and why deep learning? Because unstructured data has huge success with deep learning compared to machine learning. So that's how it all aligns and falls into one place. And before I jump into, I'm not sure if Partha introduced himself. So we are from PayPal. So we have 3 workshops. So this is one of the 3 workshops. So one happened yesterday, I think, and there is one tomorrow as well. So it all revolves around deep learning, text analytics, and all those things, right? So all of us are from PayPal. So we work on different data science themes. Like I particularly work with fraud. For example, Satish, who will be coming next, he works on merchant and marketing and all those things. So we'll try to give you some use cases from PayPal as well, right? Because at the end of the day, that's what we wanted to sell as well. So how whatever we are talking, whatever that Partha showed you, how can we translate that to a business problem in PayPal? So we'll also spend some time on that. So that's about the introduction. So before I jump in, I want to hear from you. Can you give some examples of text, using text for AI ML use case? Any practical day-to-day use that you have? Chatbot. Okay, fine. ChatGPT. Okay, so you are becoming more trending. Okay, fine. Okay, so you're wow. So you combine the previous session with my session. Thank you. Yeah, right. Okay. Translation. Okay. Anything that you use day to day, someone uses right now. You chat and spell check recommendations, right? Sentiment score from social media. Okay. YouTube subtitles. Okay. Wow. Any one more use case? Anything very more interesting? Transcription, subtitles, kind of thing. Translation. Okay, great. Right. So yeah. So you all already are familiar of some of the use cases of text, right? So I'll just give you some overview of how can we model a simple text. If I say that this mobile phone is stupid, right? So you should understand that this mobile phone is not good. So how does the machine understand a sentence that says this mobile phone is stupid, and it understands that it actually means not good, right? So that's exactly what I am going to cover, and then I leave to the next colleague who builds from on the top of it, and then we will see how this can be leveraged in ChatGPT or in advanced kind of tools. Images are challenging, they are computationally expensive, but text has one more complexity to it, right? So that is particularly this example I put in a slide. So do you think Siri did a good job? No. But from an English perspective, it did a good job, right? I mean, like, you go to a dictionary, you comprehend what that dialogue was, it really did what it is meant to do, right? And but there was just that social engineering concept to it. You understood it, calling a cab actually is booking an Ola. I mean, like, how does Siri know that? That's something your world has it, not Siri's world, right? So why it is being complicated is, you are telling the computer that this is the meaning, and you are also telling the computer that don't interpret it this way. So you give a question, you give 2 answers, and you ask Siri to choose the answer, right? So that's why it gets more complicated, and we will see how to deal with it. And one more precursor, there was a very interesting question about the images, right? So what do we do with Chinese or people with different kind of skin tone or different images? How do we account for that, right? So can anyone say what's happening with the yellow color image? I mean, this one, sampling bias, that image. Balanced. I mean, like, just read it. What do you understand? Right. Right. So basically, people who do not like to answer surveys, they didn't even participate. Right. So that's basically what Partha was saying in the previous session. So when you are like catering to a crowd, you should have data point from everyone in the crowd, right? So maybe if I have some data about those people who tossed the mail into the bin in this chart, then maybe I make sense. But I should not only go to people who responded surveys and got their interest. Obviously they are interested, that's why they are responding to you, right? So that is that sampling bias I just want to explain. Okay, let's just switch back to text. So text, when you have image, text, audio, video, whatever, first step is convert them into a numerical form or a tabular form, and then you can do all your usual modeling things that you learned in your coursework, right? So the main challenge is how you convert. So in image, organically it is in a pixel format, right? So you have this pixel format and 1080 cross 1080 nice matrix with RGB values. So you all have that. In text, you have to do that dirty work of creating that particular table, and there are many ways to do it. So first is clean the text, right? Because it's not at all clean. You use stickers, emotions, smileys, or you use your own typos, and so you just complicate it as much as you can, right? And you will clean all those text, and then you will create that numerical table I'm talking about. So convert text into some numerical, right? So if you convert that numerical, then you can use the actual algorithms that you learned, right? So that's the third part. So you have three parts. So first is pre-processing, and then is the way that you create the numerical version of it, which is called feature creation, and then finally you can build any model you want on the top of it, right? So I'll if there is time, I'll get back to this example. So I'll just skip for now, right? Okay. So why is text pre-processing needed, right? So this is one review from Zomato. So if you see, the word amazing is in caps, all caps. You have some URL, you have symbols like at, and this person is very kind, but many of you even won't even type pi, you will just put the symbol pi, right? So you'll just complicate it. So when you have such kind of reviews text, right, thumbs up, thumbs down, or something like that, then it's better you get rid of it if you have a large corpus, right? So today you have advanced ways through which you can even use that particular knowledge, but to make things simple, let's get rid of non-English characters for now, right? So if that's the motto, I will get rid of this at, right, and then I will get rid of this URL that I have, and the computer just sees these as characters. So it's going to think the capital amazing and small letter amazing are different. That's what it is going to think, right? So to make it common, you should make sure everything is in same case, right? So have you heard of scaling in your regular modeling, right? So you do scaling, you make sure everything is in the same range, 0 to 1 and all. So very similarly in the text world, you have to make sure that whatever text you are dealing with, it's in the same case, right? So that the computer doesn't mistake that a capital amazing is different from a small amazing, right? So this is one pre-processing I can do. I can put in small case, I can remove all these URLs and stuff, I can remove symbols, right? So let's just look at it. Yeah, so these are some of the things that we identified. So you can convert to lowercase, you can remove symbols, punctuations, and numbers. Do you need numbers? What do you think? Depends on context, right? So if I'm talking about COVID, right? COVID-19, COVID-23, COVID-24, I don't know, right? So numbers are very important in that context. If I strip numbers, it's all going to be COVID, right? So it depends on context, of course. And Stop word removal. Anyone know about this? Can you think of an analogous in the numerical world? Have you heard of outliers? Right. So, so, so basically, not everything in text is important. Only the content is important, right? So that's taken care by stop word removal, and then you have some other things that we'll get into. But generally, these are some foundational pre-processing steps. If you have to take care before converting your text to numbers. If you skip this step, I mean, like, you will still get results, but you won't get better results. That's it. So let's take one example, right? So IIT Madras online degrees teaching NLP course. So I said that at the end of the day, computer cannot read text, right? So every text, every character, I, T, all those things has some bytes mapping, right? So there is a character encoding to it, right? So a capital I will be something, a small I will be something, and the computer at the end of the day sees that only, right? So you have a defined set of encodings, and I'm not sure if many of you have heard. You might have heard of this term called ASCII, right? ASCII encode, right? So it's the American standard interchange, information interchange thing. So first step is, whenever you have a text, I'll just skip few slides, right? So you have some encodings like this, which are in binary bits format. So you have like capital A, there is one number, ampersand, there is one number. So you have something for everything, every unique character out there, right? And one standard is this ASCII, American Standard Code for Information Interchange. So when we get a text, it's better we encode using ASCII. The reason being, if you type a random character which does not even exist, right? When you encode, will that have an encoding? No. So you can easily get rid of it, right? So that is one way of filtering those characters. So for example, if you have used WhatsApp and if you miss some updates, some stickers come as boxes for you, right? So basically that didn't have an encoding. That's what it means. So ASCII is one common way, but there is a drawback in ASCII. You have predefined values like this, but it's only for American English, right? It doesn't support other languages. So let's complicate again, right? So is this O an English O? No. So it's German, Schrodinger, right? So when I have to take care of multilingual text, encoding for any kind of character, universal language, then I go to some universal encoding, which is something like UTF, right? So which is an example of universal encoding. So this is to give you an idea of first pre-processing step, which is encoding, right? If you're dealing with English, American English, go for ASCII. If you're dealing with universal text, go for UTF. This helps you filter out junk characters. So at the end of the day, when you encode, you will get only whatever that is kind of could be processed by the system, right? So when you do that, so when you do that, then you can go to the next set of simple things, which is straightforward, right? Convert to lowercase, remove symbols, punctuations, numbers. It's very straightforward. So you write some simple rules that takes care of those processes. For example, remove everything that's HTTPS, meaning remove URLs, right? So, and then you have predefined set of symbols, at, / punctuations, anything remove. So you can write simple rules, and this can be very easily done, okay? So for example, lowercase, this is how the output looks like. So now everything is in a single case, right? And now if you see, punctuations are removed. There's an exclamation after ME2, it's removed, and then you have semicolon, that's also removed, right? So you have rejects, regular expressions. So people who took Python might understand that. So you can take care of all these removals using those syntaxes. Okay, so now let's go to stop word, right? So let's have something like about Dr. APJ Abdul Kalam sir. So here, if you see in this, to understand about him, Do you really need to understand on, in, go? Why not, right? So what you need is, he's a leader, he's one of the greatest presidents, he's a brilliant scientist. That's all you need. Remaining is too much additional info, right? So generally, how can you find stop words? As a layman, don't forget mathematics, forget AAM. I mean, generally, what in a text is useless for you? Connectors. Okay, let me go one step beyond. Why do you think conjunctions are useless? Why does that don't convey any meaning? Independently. Okay. One step even backwards. Okay. Let's say we are having a debate about cricket. Okay, I'm just transcribing whatever you say. Is the word cricket important in this debate? But every one of you is going to talk about cricket, and everyone is going to use the word cricket, right? Now, is the word cricket important? No, because it's something that's very obvious that anyone is using. I mean, like, it's not that unique or it's conveying any special information, right? So similarly, that's exactly why this conjunction is also not important. That's what I'm trying to bring to the table. So it's because it's present in everything. It's not going to convey any special thing to you, right? So if you talk about something that's on a theme, anything related to that theme is not important, because everyone will talk that. Everyone will use the word cricket. Everyone will use the word bat, ball, runs. So you want to go beyond that and see what they are talking about cricket, right? So stop words generally are of two types. One is these English kind of things, which are like prepositions, conjunctions, articles, and all those things. Other is also contextually obvious words, right? So how will you actually find that? That's actually pretty simple. So I'll show you one graph, right? So you can get rid of the most frequent words of the corpus, because that's out there everywhere. You are not going to learn anything new from it. And then you can also get rid of the bottom, right? So one very simple way, I mean, like, very naive way, is do frequency count, top 5%, bottom 5%, just cut, right? So what is important is the average or the centrality of it, right? So you can use stop words like this way. You have predefined English stop words, but you have to also use custom stop words, which I'll show you in the tutorial as well. So you have to add your own stop words. If you are doing an interview of Dhoni, make sure you add Dhoni as a stop word, because everyone is going to say Dhoni, right? So that's what it is, right? Fine. And last part, tokenization in stemming. I'll come there, and then we'll jump to a tutorial. So tokenization is, what is your unit of modeling, right? So am I going to model at the word level, or at the sentence level, or at a paragraph level, or a document level, right? So what is the unit at which you are going to build that table that I'm talking about? So sometimes the table itself can be at the document level, or at a word level, or character level, right? So in this example, it is word level. So I have basically split the text in terms of words, because I'm going to model at the word level in this case, right? Okay. So stemming and lemmatization. Before that, any doubts till now? So this particular context works well when you have a large corpora. So you should have I should have all the essays of or news articles of Dr. APJ Abdul Kalam, and then I want to judge him based on what everyone talked about him, right? Not just on Browse. So basically, the idea of all this pre-processing, what it is to reduce the number of words. So when all that I have is only these many words, I am okay considering all the words, right? So only when I have millions of words, I want to do this pre-processing and get rid of all the words. So I don't have unnecessary words. So that's that. Anything else? Right. You are actually very right. So you can also use punctuations, emoticons, everything. So just that I want to start from basics of a very simple way. So today you also use punctuations and other things. Yes. Okay. So so as I said, the objective is to reduce the number of words. So if I give you 1,000 words, after pre-processing I should have maybe 100 words. That's all. So that's my entire objective. So the table I am building is very small, not so big. So in that case, I can do this as well. Why should I have playing, plays, played, everything separately? Put everything as play, right? So it can be grammatically irrelevant. That's fine. The computer is not looking for grammar. It has to understand that whenever there is a word stupid, it's negative. That's all. So you make sure that different formats of that word is in common format. That's all, right? So here what I have done is, if you see going became go, that's okay. Goes became GOE, right? That's because stemming generally you just put some rules, that's all. So the rule here is cut yes, trim yes, trim ing. So I can trim yes from GOES, it becomes GOE. So GOE actually is not a proper word, but that's what it is, right? So my objective is not to make it English or grammatically correct. My objective is to make sure the words are consistent. That's all, right? So this is one way. It's called stemming. You have rules to remove these ed, es, yes kind of things. There is also lemmatization, which is the proper way. You go to the dictionary, actually check the root and put that, right? So which is time consuming? Lemmatization, because you have to go to the dictionary, see what it is and come back. So when you have large text, you cannot do this, although it is so accurate, because it's exponentially time consuming, right? Okay, so now you know what a pre-processing is. For example, this is one pre-processing stemming example. If you see, it's not grammatically correct. It's just following some rules, right? Similarly, this is on lemmatization example. Okay, so now you know what are the pre-processing stuffs, right? So I'll just show a quick demo and then we can wrap, right? So I have mobile reviews here, okay? So camera not good, screen awesome, all those things are there. And someone has read that review and has told me it's negative, positive, negative, positive, right? So you have labels, you have the text. Now if you see, whenever the word not comes, it's negative. That's the pattern you want that particular machine to learn, right? So let's just see how we bring that. So what I'm going to do is, I'm going to take all the unique words and put a table. I took all the unique words out there, I built a table, and I have all the reviews. So when in first review, the word camera is there, not is there, good is there. So I'm going to fill those values, 1, 1, 1. It occurred once, and then remaining all will be 0, right? So now what happens? How many ever reviews I have, after pre-processing, I build this table where I have all the unique words. If that review has a word, there will be value of the count, otherwise it's 0, right? And now I have positive, negative. Now I can give it to a simple model, logistic regression or anything. I'll just pass this, and it will now learn that whenever not has a value present, it is actually negative, right? Yeah, right. For example, it cannot understand sarcasm or this word sense disambiguation or everything. So that's where we have advanced things, but into this you will have emotions as well built in. But this is like a simple example I'm giving you, how to convert a text into a table. So this is one way you can convert. So like this, there are multiple ways you can convert, where those shortcomings also will be taken care of. Right, you want to portray it, right? Yeah, right. Right. But again, you gave that complication as well. How do I know you are excited or angry? Right? You will say that amazing and 10 exclamations. I mean, you can be angry and sarcastic, or you can be really excited. Right. No, I mean, like, you are absolutely right. I'm just giving you the idea of why it's very complicated. It can be done, but just that you will always have people who use caps for sarcasm, you have people who use caps for anger. Just that you can do all those things, but it won't be perfect. So you will always have edge or corner cases, someone where you will miss it. Yeah, so this is simple idea, but let's take another example. So this is one sentence I have, this is another sentence I have. The red ones are the useless words or stop words I don't want, so I'm stripping them off. And then I have these words, then I build this table, I put all the counts, and then you can model. So whatever I call right now, it's one way of converting text to numbers. It's called the bag of words model, right? So like that you have a small adaptation. So why just take count? Take count into something else, right? So that is called as TF-IDF, but I don't want to jump into the details because my objective is to tell you that these different formats of creating this table exists. That's my objective, right? Okay, so now I'll just show you some demo. Yeah, I think I'm good with time. Okay, I think I can complete TF-IDF as well. So in TF-IDF, what we do, previously I just took the count, right? If a word, how many times it's present, I took it directly, right? So here what I'm going to do is I'm going to take the count and I'm going to have another formula out there. This word, how many reviews, in other reviews also this word is present, right? So if this word is present in all the reviews, is it important or not important? Important? It's so common, right? So it's not important, right? Because everyone is talking about it, so there is nothing unique coming from you, right? So this, doing it this way, you can put the numbers like this. I'm just giving some examples. These are not count numbers, these are numbers that says higher the number, it's more specific to this person and it's less common across other people, right? So these kind of numbers make more sense. Some of the challenges that we discussed could be addressed here in some way. So like that you have many complicated ways of doing it. I'm just giving an overview of how a simple text can be converted into a review. Okay, so now let's just see some demos. So I told you, now can this be used for sentiment analysis? If someone does the manual work of going through every review and gives you its positive or negative, you can do, right? So you know someone identified a text as positive or negative, you know the text, you can train a model and then you can, future text you can predict it, right? So it's all possible. So I'll show you some example of, so this is just a demo. So don't worry about the code, you can use any tool, anything, but I want to just tell you that this use case is possible, right? So what I'm going to do now is, I'm going to access Twitter and anyone can pull tweets, right? So you can ask for any hashtag, let's say hashtag Dhoni, hashtag IPL 2023. It pulls you all the tweets that are tweeted in that hashtag. So you can ask for count, let's say I can ask for 1000 tweets. It will give me most recent 1000 tweets about hashtag IPL 2023. I can do the text pre-processing I talked about. I can then build my own model or I can use a pre-built model, right? So in this case, I have a pre-built sentiment classifier. So I'm going to pass these tweets to that and check what those tweets are talking about, right? So sentiment, what are, how many classes it has? Should it be only 2, right? So as someone pointed out, it could be emotions as well, right? So what I'm going to show you is like an advanced version of sentiment where it's emotion. So if you give a tweet, you can see if it's angry, it's anticipation or trust, or it's joy, sadness. There are so many emotions, right? So they're predefined emotions. So this library can predict directly what is the emotion of the text. So we'll just see how that works. So, and how do we do that? Very simple, go to developer.twitter.com, create an account for yourself, and you will get your API key, access token, secret keys, everything, right? So you just copy paste it in your code and it should work. That's all. So, so let's just see. So I'm just asking for, let's say, hashtag Dhoni, okay, and I'm asking for only English tweets, most recent 1000. That's what I'm asking for. Okay, so let's see how does it come. It might take a minute or so. Okay. Yeah, so you got some tweets, right? So it looks like this. It's like it's in a CSV format. There are, you see many retweets and all those things. You have other details as well. When was this tweet put? Which ID? Was there any replies? And all those things, right? So, but we are only interested in the tweets. We are not interested in anything else. And you see, it needs pre-processing. It has stickers and it has these usernames which are not relevant for you. So you have to pre-process and make sure you have only clean text, and then you have to pass it to your library. So let's do that, and that's exactly what I'm doing here. Okay, I'm removing punctuations, retweets, HTTP URLs, and all those things, numbers, everything, and we will get a library and we will directly predict what people talk about, right? So you will directly get to know the emotions. I'll just show you that. I'm not sure why Dhoni's emotions take this much time. Okay. Okay, so this is what it is, right? So you have pre-built emotions out there. Okay, so these are pre-built, predefined. It's a library that is already trained on a large corpora to predict these emotions. And you see on the tweets, mostly it's positive. You have a lot of trust and you have anticipation. That's surprising. Any reason why? Winning the cup, last IPL or not, right? So such kind of discussions are also happening in Twitter. That's why you see the emotions, right? So now think about this use case. I just showed you something, but if you have something like this, you can use this in various places, right? Product analytics or movie analytics or go to market strategies, so many things. What people talk about my organization or product online, I can pull it, I can check the general trending emotions, and with that you can extract various insights, right? So let's also deep dive, and some of you might be aware of a word cloud, right? So let's see how the entire text words look like, right? So bigger the word, more frequently talked about, less size the word, it's not that great. So these are the top words discussed. And any idea why the word Dhoni looks bigger? Because everyone is using that word, and that's exactly what I said. Now if I have to, now is this a great insight? I know it's about Dhoni, and of course people say Dhoni, right? So I have to make sure I add Dhoni to my stop words, and as Dhoni is removed from my words, now I'll get a new word. If that word is also obvious, I will again put that in stop word, right? So I'll do this iteratively until I get something that's meaningful. Yeah, I'm unable to zoom. Yeah. Okay, for some reason I'm unable to zoom, but generally you see that it's Dhoni, it's CSK, stadium, respect, such kind of words, right? So you can just deep dive and see, you will get more and more words that are more contemporary. So yeah, anything else? Your choice. We want to discuss or search for any other hashtag. Sorry? BS degree. Okay. But do we have an active tweet tag? I don't know that. So, but maybe I don't know. So is it BS degree? IITM, BS, IITM online. Okay. The only thing is it's exact keyword search. It exactly looks for these words, right? So if there aren't much tweets, we don't get it. But let's just check. There's nothing wrong in checking. Yeah, you see, you have 0 tweets. IITM, BS online degree, is it? Or I'm pretty sure we might get the same. Yeah. So if something is very trending, I think you will get good tweets. ChatGPT. Okay. Yeah, it's pulling some tweets. Anyone using ChatGPT for your online assignments? Okay, this session is recorded. So what right now is happening is all these texts are being passed to this library, and it's a pre-trained model, and it's predicting what, it's a multi-class classification, right? So it predicts what exactly is the output. Okay. So positive fear is there. Okay. Some anger is there. Maybe that's from faculty, I think. Right. So some disgust, but yeah, hugely positive and joy. Right. So maybe just to know that, just to get a flavor of different emotions, I tried this. Let me show you. There is a Kerala story, right? Right. So maybe let's see, is it really able to capture different emotions of people? So what do we expect from this? Any idea? Anger. Okay. Let's check it out. So for example, let's say iPhone is launching its next version. There is a hashtag called #iPhone problems, right? So if someone has any problem with iPhone, they can just go and put #iPhone problem. So they can gather all these tweets and they can analyze what are the next things they have to address in the next version. Let's say battery is poor. So that is one kind of use case where you can use this. Or you can do movie analytics. Yeah. Okay. So yeah. So you can see that there is a lot of fear, and you can see there is a lot of anger as well, right? So it's, you can see a little bit of shift in other emotions. So it's not just anything you give, it always says positive, positive, positive. So something that you see is contemporary, you can just try it, and you can actually get the public sense out of it or public trend out of it, right? Yeah. Any last hashtag? No politics. Okay. So any other IPL team? Anyone? I don't know, wherever I go I get this only. Any RCB fans? It's taking more and more time, right? Right. Okay. Fear. Negative, yeah, maybe because people are little bit angry, maybe the fans right now, that they are not able to make it up or something like that. But you can, this gives you the sense, right? Little bit of anger, trust is still there. So yeah, that's positive, right? So this kind of gives you the sense. But the underlying thing that I want to highlight here is what goes behind this is that dirty pre-processing I talked about, and then you build some model. And once you have such a framework built on large scale data, imagine, I'm talking about tweets, imagine this being done in Wikipedia text, Google search, news articles, everything. You can build something that could be super smart as much as like a ChatGPT or things like that, right? What is the 26 element? I didn't know. Oh, you want to try for that hashtag? Yeah, any idea why? So basically, in a very naive setting, neutral by default is being pushed to positive, right? So many people could be neutral, but by default it's going to be positive. So that's why. Yeah, yeah. Someone was saying, any last thing that I should do? Or, let me do a quick. Yeah, I have 2 minutes. Sorry. But I don't know the exact keyword. Do you know it? I don't know. Right. So it's very old. No politics. So, fine. Okay. So fine. And I'll give you one more demo before my laptop switches off. Right. So using ChatGPT. So I understood that, yeah, all of them are using it for assignments, but I'll show you another use case where you can be benefited from ChatGPT. So here you have ChatGPT, right? Yeah. So you can use it for chatting. You can use it for your data science also, right? So you can use it for writing codes. Anyone tested it, right? It does a good job, right? Right, so started writing, right? So you can use the first use case is you can use to optimize your codes as so. So you can say, can you make it better? And if you're not really good at data structures, it will do that for you. And another is embeddings. Anyone familiar with, not familiar with embeddings? Or most of you heard of it, right? Okay, got it, right? So embeddings are nothing but any entity can be converted into a number, right? So as I said, the text, image, whatever. And the idea of embeddings is similar entities will have numbers closer to each other, right? So if I'm a data scientist has an embedding of 0.41, and then I work in data science will have something like 0.39. It, but I work as a music conductor will have something like negative 0.9. So the idea is you have numbers that are very close to each other contextually, and when you have something like that, you can use it for a lot of use cases. You can segment, you can group, and all those things. And ChatGPT can do it for you. So can you create? Okay, let me directly ask. Yeah, even that it can do, right? So this is through conversations I'm talking about, but you can do it through Python. So if you see here, what I have done here is I've done all the pre-processing and I've taken Zomato reviews. I opened an OpenAI account, went to settings and got my API key. That's all, very similar to Twitter. And then I wrote one code that says get underscore embedding, which is from OpenAI. And I'm passing, they have so many different models. So I'm asking for one model and I'm passing my review column of my pandas data frame. So now you see I get the embeddings. So you can use ChatGPT for these kind of use cases as well, where you get these embeddings, and with these embeddings you can do whatever you want, right? Train a sentiment analysis classifier, do clustering, segmentation. So ChatGPT does that work of converting the text to a number, which is the toughest part. Now you can do anything you want with that number, right? So with that, and yeah, so I think I got that embeddings, I did some clustering, and you can see, and I asked the ChatGPT itself, can you explain each cluster? And it's explaining me that cluster 0, all the reviews are about quality of food service ambience, right? And then cluster 2 is about only delivery. So it explains that also. So you can use ChatGPT for these things as well, in addition to assignments. That's exactly what I wanted to give you. So I stop here. In the next session, you will see how this works, right? So Satish is going to explain you how exactly this GPT is working. So now you got a flavor of how text to number happens, but how exactly GPT works is something we will see next. But do you need a break? Okay, got it. So maybe Satish will start in 5 minutes. Thank you.